An Introduction to Electrochemical Discharge Machining (ECDM) process and its research potentials. By Sahil Grover, Viveksheel Rajput, Vikas Yadav, Sanjay Kumar Mangal, Sarbeet Singh, and Sanjeev Kumar. To machine difficult-to-cut materials including ceramics, glass, and silicon wafers, a hybrid and widely recognized process known as electrochemical discharge machining (ECDM) is used. It employs the working principle of electrochemical machining (ECM) and electric discharge machining (EDM) processes to remove the material by combining chemical etching with thermal melting. The materials machined using ECDM exhibits enormous implementations in the field of MEMS and lab-on-chip. Different facets of the ECDM process have been researched in an effort to escalate its effectiveness ever since it was originally shown. The present chapter discusses the critical research potentials of the ECDM process that was documented in the past decades. Additionally, it covers the impact of several input process factors, including electrical, electrolyte, and tool electrode, on ECDM performance. A summarized report on ECDM hybridization and variants are also given in a lucid manner. It also identifies future directions that might enhance the ECDM process's overall machining performance. It is concluded that with the help of gas film dynamics controlled by variables such as electrolyte characteristics and tool motions, ECDM can machine non-conductive materials with precision. Pulsed voltage, suggested electrolytes, NaOH, KOH, and regulated tool properties, material, shape, and rotation, are important factors. Spherical tool electrodes help minimize overcut and taper comparative to other tools, while machining depth and geometrical accuracies can be further improved by implementing hybridization such as magnetic assistance and ultrasonic assistance. Thank you for watching this video. Please subscribe our channel for watch more scientific research videos.